Round of applause for Milad, everybody.
Thank you. Good. Thank you. Hello, everyone. Thanks for coming here tonight. My name is Milad, and my talk is a lightning talk, very short, small, so I don't go through details. I'll try to get to the demoing part, maybe demoing two things, but feel free to interrupt me and ask any question if there is any question. So I'm going to talk about reflection in Go, and this is okay. Reflection in Go, and one use case for it that I found it very helpful. So has anyone used reflection in Go or other languages, or how many people? Anyone liked reflection? Okay, cool. So basically, assembly was the first language that was reflective. You could access any memory address and make any changes you want to it. And as we were moving toward more high-level languages, the reflectiveness, were gone. But at some point, we thought, having a reflective language is a good idea, so we brought it back into our languages, programming languages. So to be a little bit more formal, reflection is the ability of a language to discover the structure of a program and create new execution passes as the program is running. And there are not many use cases for reflections, but there are some important use cases. Generate metaprogramming, with software testing, mocking, and assertion. The assert library, require library, and mock library in Go, they're all using reflections. And in software verification, reflection can be used for monitoring the states of your application and asserting temporal logics queries to prevent like data races and deadlocks and things like those. And also in dynamically changing environment like network environments and unknown environments that the underlying infrastructure is changing, reflection can be used for changing, for example, your data types, the size of your integers, things like those. And you can extend the capabilities of your application without changing the source code. Some consideration: reflection is dangerous. Many things can go wrong. It has like a huge runtime overhead, and there are security concerns about it. And you can use reflection in Go using the reflect package, and you can use it for kind of mimicking generics in Go and accessing unexported fields on your structs, unexported functions, calling them. It's not recommended, but that's what you can do with reflection. And basically any reflective programming. And effective use of reflection requires a plan. And by a plan, I mean that you need to limit it. You need to build basically like a framework or library, or create like a new DSL, a domain-specific language, to use reflection effectively. Rob Pike has written a blog post on laws of reflection in Go, so you can refer to that and learn more about reflection in Go. And the next topic is the 12-factor app, which I assume that many of you have heard of it. It was proposed before the containerization technology is becoming popular, but it's so relevant today. And by relevant, I mean that if you stick to the 12 principles proposed there, you can easily scale your applications, deploy it to different environments, and basically making it agnostic about where it's being run. Is it like Kubernetes? Is it serverless? Is it Docker and so on, wherever you run it? And the third principle there says that everything about your application, the configuration, should be managed as environmental variables. That's the standard way of doing configuration management for your applications. So again, you can read more about this. And now let's get to the problem. One problem that I find myself like again and again and again every time, especially with microservices day, that everyone wants to do microservices, is that I found myself repeating a lot myself every time I wanted to create a new application to basically do the configuration management properly. First reading the configurations from flags, and if not setting flag, reading them from environmental variables. If not there, sometimes you need to read them from false, and then you need to also convert them to the right type, int, float, whatever, and handle the error. So it's a lot of like boilerplate across like every application. So I wanted just to get rid of the boilerplate. So the solution is, one solution is using reflection. Basically, with reflection, you can define just a struct, and the name of environment variables can be inferred from the name of your struct fields. And similarly, the type that are needed, they can be inferred from the type of your struct fields. And I built like a small library config with K that I have been using it for over 2 years, and it's been used in different production applications. So I just wanted to share it with you today. And so I just start with doing a little bit of demo. So I recorded this demo with ASCII Cinema. If you haven't used it, it's great. Just check it out. So I start by looking at my main.go. So as you see, I just define like a struct with some fields in it, port, log level, timeout, and different hosts. You can see that you can use like built-in Go types like time duration, URL, things like those. And I can also set some defaults on my struct. And all I do is just call config.pick, and that's it. So one way of like passing the configuration to my application is through flags, runtime flags. So the first way of basically doing that is using flags. So these are the default values. Port 88, log level is info, and the timeout is 2 minutes. And now, next I try to pass some flags. I want to pass a list of Mongo for local, for testing, for example, and different set of configuration values. Now the port is different, log verbosity is verbose, and 3 different Mongo hosts. So if I don't want to do that and I want to do it through environmental variables, I can just set environmental variables. Look at the name of environmental variables. They're all almost the same as the name of struct fields. And so a set of different. And if I want to read them from false, I can first write my values to different false. Again, the name of false, they're all inferred from the name of my struct fields. And then I can pass the path to my false using environmental variables. So I won't violate the 12-factor app principles. I still do everything through environmental variables. And next, if I run it with dash help, you see that all those configuration variables, they're all added to the help of my binary, so you can inspect them. And it also has like a debug option that you can basically inspect what exactly is going on. First, the flag is read, second, environmental variable, and third, false. So this was the basic demo. Next, I want to do a demo about how we can do dynamic configuration management. With dynamic configuration management, I mean that, let's say that you have a stateless application running in Kubernetes and you have a long-running job that takes a couple of minutes, and you notice that something is wrong and you want to increase the verbosity of your loggers. But if you change the config map and restart your pods, you're going to lose and basically cancel your job that is being run. So without restarting your pods while your job is getting done, you want to change, for example, verbosity level for your logger. Or if your secret is rotated, you want to be able to pick up the new secrets. And this config library allows you to do that. So you can change the configuration values. And the only thing you have to do is implement the logic for reconfiguring your service. And I'm going to show that next here. So, yeah. So this is again my Go code. I only define a struct and I make a reference to sync.mutex. So my struct is go routine safe, so I can lock it and unlock it. So I won't have any race condition and those kind of scenarios. And then I set like a default value. I create my logger. And then inside the Go routine, I listen for updates. If there is any update, I lock my configuration struct. I read the new log level, I unlock it, and then I use my the new configuration value in whatever way I need to. In this case, changing the logger level. And then instead of calling the config.pick, you won't see it here, unfortunately, but I call the config.watch, which basically watches for new incoming changes. So this is like the server code. Next is the client code, which is very similar. I again define just a struct with a reference to syncs.mutex to not have any race condition scenario. With some defaults, I create my logger, and then I only implement my reconfiguration logic. So if there is any update and if I'm interested in that update, I do whatever I need to do. And again, I just make a call to watch on this struct. And everything else is just the client logic that every 5 seconds makes a call to server. And now let's look at, if you're familiar with Kubernetes, let's look at the deployment file. In the deployment file, I only set like an environmental variable. And I would set like an environmental variable to tell my pod or application where to read the values from. It's just a volume. It's mounted from a config map. So this is the deployment for server. The deployment for client is very similar. All I need to do is setting environmental variables and tell my application which files to read the configuration values from. And the configuration files are just mounted volumes that the Kubernetes mounts them. And whenever there is like a change to config map, Kubernetes inject those changes into your pod. Either they're config maps or secrets. So currently my config maps log levels are set to warn. So I would only see warn level logs. And in this example, I have four pods. 2 of them are client, 2 of them are servers. And I take a look at the logs for each of them, and they just say, OK, it started sending requests, it started server. There is not much about what's going on. And now I want to know what exactly going on, and I want to change the verbosity of my loggers in all of those pods without restarting them. So I go ahead and make changes to config map. So here I change the config maps log level to debug, let's say, for the client. And I will do the same for the server. So I change the config map log level from warn to debug. And that's all I need to do. So in this case, I don't need to scale down or scale up or make dummy changes to my deployments to get the pods, picking up the new values. So I'm running my cluster in Google Cloud, and I still have 4 pods. I haven't restarted them. They have been running. And now let's take a look at the logs from each of the pods. So the first client already has changed the first, I see it here, not there yet. Sorry. OK. Yeah, as you see that my clients and server now started to log every request because now they're logging in debug level. And this happened without restarting them. They were just able to reconfigure themselves. And yep, that's it. So going back here, so these were, I had another demo that I'm gonna skip it, but if you're familiar with Telepresence, you can use config for enabling your application with Telepresence. So Telepresence is a CNCF project that allows you to run your Go binaries from your local machine as they're running in your remote cluster. So every request from the cluster gets forwarded to your local machine and vice versa, and you have access to all files, all things. So that's useful for debugging, an application, making changes to binary, compile it, run it on your local machine as it's running in the cloud. And in terms of future works, secrets are special configurations. So, and they are an exception to 12-factor app, because secrets needs to be encrypted at rest and in transit. So you don't want them be available in your environment. So if you run the env command, you would see them. So secrets needs to be read from secret managers. And one extension to this library would be adding support for secret managers like Vault or AWS KMS or Google Cloud Secret Manager. So that's it for me.